Hello, I'm Dr. Hyungkyun Shin. I'm the sixth speaker in session 5, and there'll be big giveaway, lucky draw on offline audience. Please bear with me a little bit. So this is on live streaming to overseas offices for the first time. Thank you, Chairman Gyokche, President Amgan Taekwan and others who put this together. Thank you, Dr. Kunul Lee, who is moderating, chairing the session. Thank you, Dr. Jaejun Ryu, who taught me a lot during my PhD years. I use intraoral scanner CEREC Blue Cam since 11 years ago, and I've been doing a digital guided implant lectures at YC for the last 3 years. I can feel 3D printing technology is rapidly developing and widespread, getting popular for the last 2 to 3 years. So there are many 3D printers, and how can you use 3D printers in a smart way? It means it can be used without stress in many cases. I'm going to talk about how to use or choose the 3D printers and in what cases can we use them. I spent tens of thousands won to buy the printers and spend so much time. And so this is the contents. I'm going to introduce the 3D printers, and I'm going to talk about DLP LCD printers. I recommend how to use them clinically. So let's go to the basic. What is the 3D printing? Using three-dimensional model data, the materials are built layer by layer. So it is called additive manufacturing, layer by layer, point by point. They are built up. So it is used in various industries. So many different 3D printers are used. 3D printer-related patents began to expire from 2012. So there are so many different 3D printers. But if you look at the operation mechanism, they are indicated in a blue color. They can be used in dental clinics. So there are so many complicated operation methods. What can we do? When you purchase 3D printers, there are many articles on how to choose them. And based on my experience, I can come up with 4 things to consider to choose a 3D printer. First, speed. So you print out surgical guides, and if it takes hours to print them, it is really cumbersome. Everything should be finished within working hours. Second, accuracy. Printing failures occur, so the failure rate should be low, and in order to do surgery as expected. Last, the price. Not only the device price, but maintenance cost should be low. So I think the most important thing here Sorry about this. I believe the most important thing is it is easy to use. So it should be stress-free. It should be easy to learn so that we can use it more. So it doesn't get printed just like one click. A slicing program should be used to print. The output should go through post-treatment phase and curing. So many steps to learn to use it in a smart way. And you need to consider staff training. You cannot do everything yourself. You need to check important things, and the rest should be done by the staff. And if the staff say they cannot do it and they cannot learn, your work will be increased. So you need to think about return on investment. So you need to use it more. So easy to use is very important. As I said before, 4 factors need to be considered. Many papers discuss about this, and these are reported used in dental area: SLA, DLP, MJ, and FFF. DLP and SLA is using the polymerization method. So, according to the projection light source, the curing is done. So, depending on the light source, if laser is used, SLA, and a projector light is used in DLP, and material jetting used in one guide, and fused filament fabrication FFF. These are primarily used in the dental area. I am going to talk about the DLP and LCD. DLP uses a conventional light source such as a projection source to cure surface layer. And LCD uses LED light source, but they are curing layer by layer. It is depending on the height of the object to be printed in terms of the time taken. That is the advantage. So it's complicated. So in our clinic, DLP 1J printer is used, so it is filmed. It's very fast, layer by layer. The liquid material is building an object, so this is very fast. 3D printer is used. The guide is not just coming out immediately. The pillars, those are supports, and that they needed supports. For DLP LCD printers, depending on the liquid material, so there are so many things that they can be printed, but they need to be approved by Ministry of Food and Drug Safety. So, if you use various materials in one container, it would adversely affect the output. So, surgical guide resin and temporary resin are primarily used. So purchase price and maintenance costs need to be considered according to many papers. And if you buy expensive device, you need to think about break-even point and also ROI, return on investment. So it is very important to have a low maintenance cost. So variable cost and labor cost need to be considered in purchasing. So SLA and DLP types are low in those costs. Material jetting or BJSLS are more costly than DLP. So when do we need to introduce 3D printers? That's the question I frequently receive, and this is the slide that I show. This is the dentistry workflow. 3D printer is used to print the surgical guide. It is not immediately printed. It has to go through many different steps. Data should be acquired from intraoral scanner, CBCT, and the planning process should be undertaken for designing of guide and the output. So it is not printed with one push of a button. So there are many papers, and there is a mental health related paper. Learning new knowledge is a great stress to Korean dentists. So this dentistry and others give a lot of stress to the patient, the dentist, so it should be easy to learn. So since there is a learning curve, it is recommended to take a step-by-step approach. So for guided surgery, one guide center can be used for the planning and the printing. And when you get used to it and accustomed to it, you can go to the next step, and you need to communicate with the one guide center through phone call and video conferencing. Then you can purchase a 3D printer in your clinic. That can eliminate a lot of time that is taken in the communication with the lab. So the next stage is you have the device to do the planning. Operation time reduction and dental outcome improvement are greatest advantages of the guided surgery, which is a must, not an option. So operation time is reduced, but it doesn't mean preparation time is reduced. For guided surgery, the preparation time is increased. So labor cost should be considered in selecting a 3D printer. One-jet 3D printer has these advantages. So let's look at the advantages of Osstem one-jet 3D printer. So I gave you 3 factors to be considered in choosing. First, Osstem one-jet printer, it can print very fast. One-jet DLP printer can print a surgical guide in 30 minutes and LCD 40 to 50 minutes. This is a big advantage over other printers. The layer by layer, the printing is done, reducing the printing time drastically. A whole of layer is printed at a time. Only DLP type can print many surgical guides within 30 minutes. Compared to FDM or SLA type, DLP 3D printer is the fastest. So many English abbreviations here, and you wonder what those are. Please refer to the YC guide lectures and others. So DLP is the fastest because that is very important. If you print 2 guides, if it takes 5 hours or 10 hours, it is a disaster. So you cannot stay near the printer until the wee hours of the next day. And if you just start printing and go home and come back to the office, if the printing failed, it is a big headache because the surgery is planned for the morning. So DLP LCD type of printer, it can print the guides during the lunch hour. 1 to 1.5 hours would be enough. And if you train your staff, dentists just need to check important things. The second advantage is very accurate and precise. DLP printer, 3D printers are very close to the true values consistently throughout the repeat prints according to many papers. The implant studio designed guide and the actual guide do not have discrepancies. They are very close to each other. And if you print multiple times, the deviations are very small. For precise printing, full HD projector is used, and the build plate size is 120 by 67 by 5. It can be expanded. So in order to improve that, the build size is adjusted to 120 by 67 by 0.5. So as you can see here, the full arch surgical guides, the 2 of them can be put in there. That is how it is designed. So a full size or partial size guides can be put into there. So LCD uses the 2K mono LCD panel, and array type LED is used to print evenly, consistently. The surgical guide curing takes only 2 minutes, very fast curing. That's how it is designed. And Osstem implant uses homegrown slicing program. So compared to DLP, this is very affordable. So ROI, I mentioned about that ROI. If you do not print guides, a light LCD printer is recommended. And so I tested it myself. One guide center made the polyjet type, and in one jet, the guide is printed out. They have been printed and they are rescanned, and deviation is analyzed. In terms of partial, if it is closer to green, it is closer to true values and less deviation. So there's no problem with the deviation. This is a full arch size guides have been printed, and they are rescanned, and the deviations are analyzed. They're close to green. That means one jet is good enough compared to very expensive polyjet printout. So there's no difference. Likewise, LCD and the DLP. So I compare them. We have both of them in our clinic. So we have so many 3D printers, and we printed out using DLP and LCD, and they are rescanned using Trios 4, and deviations have been analyzed. They are all green. That means the two do not have differences. So if the printer is cheaper, it doesn't mean it's of low quality. And let's look at the weights and appearance. DLP and polyjet full arch surgical guide is on the right. In terms of weight, they're about 10 grams, similar. And when they're in the mouth, adaptation checking, and there's no tilting or deviations. So the guides are delivered and the CT is taken. If you look at cross sections, no differences. So I am confident DLP can be used to do guided surgery. DLP versus LCD. Likewise, as you can see in the windows, the adaptation was okay, and both of them did not have tilting. As I said before, polyjet type printed surgical guide is elastic, so it fits where there is an undercut, but not much significant differences according to many different experiments. And in my hands, they didn't show differences. So wanted LCD is used to print a guide to do guided surgery for the first time myself. CT checker from one guide is used to check whether it is inserted okay. The third factor here I'm going to talk about is a low economic cost. So we tend to overlook the maintenance cost. We need to use consumables continuously. So VAT is a resin container. Resin tank is the term for SLA. For DLP, it's about 30,000 won. LCD, in exchanging the films, it cost $39, and DLP $23, which is very competitive. So I calculated one surgical guide, 1 kilogram. The package price is 250,000 won. For full arch, it's about 10 grams. With the supports, it doesn't exceed 15 grams. So 50 full arch surgical guides can be printed with 1 kilogram. What about the partial arch? Full arch and partial arch, if the ratio is 1:1, 75 of guides can be printed with 1 kilogram. So per guide, it's 3,301, which is $2.6 per surgical guide. So we need to think about the break-even point. When we purchase a printer, we need to think about when we can recover the cost. So for one guide, roughly it can be 60,000 won. Not only the material cost, the labor cost should be considered. If labor cost is $20 per hour, if it is 20,000 won, then we can get ROI 40,000 won per surgical guide. So if you print 125 of them, it's the break-even point. 3D printer, when you adopt it, you have to use it very frequently. So easy to learn, easy to use 3D printers need to be chosen. There's one more important thing. You need to use certified product approved by the Ministry of Food and Drug Safety. One-jet surgical guide resin and next-gen resin are compatible with a range of biocompatible sterilizable materials. So it's used in the mouth. So grade 2 approved resin should be used. This is very important. As I said before, the biggest advantage of a 1J 3D printers is easy to learn and easy to print. So one-jet slicing program is a homegrown program of Osstem. Let me introduce that. One-jet slicing program, as I said before, to print using a 3D printer, STL file is received and you cannot send it to the printer. It doesn't work. You need to attach supports, and the slicing program should be used to make them. 2 years ago, Osstem implant visited my clinic, and I told them, one-jet DLP printer, the Mimics program, which is a very good program, is used, which I use. But there are so many, too many functions. So I told Osstem, please make it very simple. So just 5 steps with the GUI interface, and they did it. It doesn't require many clicks. GUI, you need to click each step, moving the 3D model, and all these steps can be done in 1 minute. Let me show you. Here, this is the one-jet slicing program. Implant Studio. So STL file is brought in from there. So it is positioned in the plate, and it is rotated, rescaled, and supports are bent near the holes. So automatically the supports will not be attached there. So that's the off limit for the supports, and you just draw like that, and then the supports will not be attached near the holes. So manually the supports can be attached. 6 to 8 supports are connected on each hole, and I just click on the points. So if you just manually click the points on the holes, they can be completed. So compared to other programs, this is the advantage. And the wireless file transmission is enabled. One-jet LCD 3D printer uses the one-jet slicing program. It can be printed immediately by sending the file wirelessly. So you don't have to go through the manual file transmission. How can we utilize 3D printers clinically to make a surgical guides? Ortho dentists would use it for ortho appliance, but we use it primarily to make these surgical guides, temporary crowns, and immediate dentures. So let me talk about what I do here. First, the surgical guide is simple. It can be printed for surgery. So when you have 3D printer, time can be saved. This is a full case. There is a limitation to intraoral scanner, so radiographic guide is made to overcome that limitation. If you have the 3D printer, the radiographic guide is not necessary. 70-year-old patient, there's a pus and there's pain in the teeth. So perio treatment is delivered, but the things didn't improve. So all teeth will be extracted and implants will be placed in two-stage approach. After the second operation at 3 months, the loading was okay, so final prosthesis was delivered. In the process, how did I use the 3D printers? iOS, the radiographic resin is used to make the resin landmarks. This is sold on the dental site. The radiographic resin is made into landmarks to increase the accuracy of the image. So these two are merged. And in the implant studio, intraoral scanned images need to be checked. That's very important. So through that, surgical guides are designed and fabricated. More importantly, the fitting of that should be checked. Without radiographic guide, this is made, so everything is virtually done and you don't know whether it will fit or not. So there is a tool called the CT checker. After printing the guide, a patient is called in again and the CT checker is used. So in the implant studio, the estimated position is checked whether actually is realized. So CT checker is a tool for checking the drilling path through CBCT scan by attaching it to the guide hole before surgery. So it is not a very difficult process. It is available from Osstem, and you can do surgery without errors using this. CT is taken and it is checked. Through the steps, what is most important is minimize the errors. So the OIC program is available that talks about this. Temporary restoration is possible, especially for the anterior teeth. It takes a lot of time to make a long bridge, but the time can be reduced. A woman in the 40s for anterior teeth case. So during endo treatment, the final prosthesis is designed, so it's delivered. What do you think? The patient said it's too masculine and it looks too square, so it's rounded. So whenever she comes for endo treatment, the confirmation is received from the patient. So the teeth sizes have been adjusted, and the patient said it's good. So photo, it was done without the remaking, and the patient only wanted the treatment for the 4 anterior teeth. So the crowding is observed in the anterior region, and the patient doesn't want the protruded teeth. So sometimes it is hard to persuade the patient about our treatment plan. Our patients sometimes say, "Is it to increase your revenue?" So I need to show them the mock-up to show the image, and then the patient can be persuaded. And I say, "Is it okay that you have a protruded teeth?" Then they say, "I will follow your original treatment plan." If I didn't show this protruded teeth, that they wouldn't agree with me. So it is to reduce time of treatment for the posterior region. So if you print these out using the 3D printers, it would reduce the chair time. So that's the way to use the 3D printers. But the temporary printed by 3D printers, there's a limitations according to the papers. So if you have some questions, immediate denture can be made using the resin for temporary teeth. So if it is made like this, it's in white color. The gingiva can be stained with the gingiva color. In each vat, resins cannot be mixed together. So if you use surgical guide resin, you cannot mix it with other resin. So if you have a multiple 3D printers, it's okay. But if you have only one 3D printer, you need to minimize the type of liquid resin. So you can have a resin for immediate denture. So the topics are covered in the OIC lecture. You can refer to that. So this is for anteriors or a couple of premolar cases where occlusal force is not heavy. So these are all available from Dental. So this is the resin for gingiva. In our clinic, in areas where occlusal force is not heavy, immediate dentures are used in 100% of the cases. As I said before, you need to use 3D printing as much as possible to have a good return on investment. So, summary. Why do I recommend this? As I said before, Osstem one-jet printer prints very fast, and it is printing fast, precise, and the maintenance cost is very low. And Osstem implant homegrown slicing program is easy to learn, easy to print, and staff training is very easy. And if you use other companies' printers, you will realize this. I spent the tens of millions of won, and based on my experience, a DLP type 3D printer is very good for dental clinics. So the theme of the meeting is enjoyable workspace in digital dental office. So stress-free work is very important. So fast, precise 3D printers need to be used. So I hope the lecture has been helpful. Thank you for your attention.